Hey guys, today I'll be discussing where limits fail to exist, also known as when limits fail to exist, such as in which occurrences or situations do the limits fail to exist, also known as D&E, it does not exist, do not exist, that is. So the first situation that we have is when the limits or the graphs display different right and left behaviors. So let's say, for example, that we have this graph right here where we have, let me draw the graph first, where we have a graph where one line approaches 2 right here, and then the other line also approaches 2 from right here. So in this case, we want to know, or the question is asking, what is the limit of f of x as x approaches 2? So the question is asking that, but in order to find this, we have to confirm that there is a limit first. So in order to do that, what we can do here is we can take the limit of x approaches 2 plus, meaning from the right. So hence it'd be from the right here. So we'd be referring to this line right here, f of x. And we can take the limit of x approaches 2 minus, so we're talking 2 from the left. So this line is approaching from the left. So we'd be talking about this line right here of f of x. So for the 2 positive one, we would be talking about this line. So we can see clearly that as x approaches 2 from the right, the limit is clearly 2. So for this one right here, we can see that as x approaches 2 from the left, we can see that it is 1. Now, if the limit of x approaches 2 plus f of x does not equal the limit of x approaches 2 minus f of x, if the limit of x approaches 2 from the right, f of x, is not equal to the limit of x approaches 2 from the left, f of x, then there is no limit. So this limit right here, since these values are not equal, because 2 does not equal 1, this value right here, limit as x approaches 2, f of x, does not exist. So just know that. So another place where a limit does not exist is when it has unbounded behavior. So essentially what that means is, I'll make a graph of it real quick. Essentially what that means is the graph is going to look something like this. And I'll draw a little asymptote. So essentially, I'll put the asymptote at 2. Essentially what that means is the values will never reach 2, or my bad, they will get close to 2, but there is no definite value for it. So in this case, we'll say as the limit as x approaches 2, f of x does not exist. So now, why does it not exist? So the reason being why it does not exist is because as f of x approaches 2, so as f of x approaches 2, it does not come close to a single number, which we define as L. So basically, it's just going to keep on going up and up and up and up forever. So hence, the limit does not exist. So this is called unbounded behavior, and it's another place where the limit does not exist. So the final place where a limit does not exist is when it has oscillating behavior. This is for sine graphs and all the trig graphs essentially. So basically, the graph is going to look something like this. Do this, then we'll do this, and as it approaches 0, it's going to go like that. And then it's going to go down, it's going to go up, and it's going to go like this. So on a table side of things, let's say we wanted to take the limit of x approaches 0 of sine over 1x. So from a table side of things, it's going to have values such as this. So we'll plug in something like 2 pi, and we'll get 1. Then we'll plug in 2 over 3 pi, and we'll get negative 1. Then we'll plug in 2 5 over pi, then we'll get 1 again. Then we'll plug in 2 7 over pi, and we'll get negative 1. And then it basically just keeps on going because these numbers are slowly approaching 0, but then it's just going to keep on going from being 1, negative 1, 1, negative 1, 1, negative 1. And because of this, the limit does not exist here. I wouldn't worry about this one too much because this limit isn't rarely tested in calculus exactly. It's most likely tested in BC and integral calculus. But yeah, if this video helped you, I hope you guys enjoyed it, and if it helped you, please subscribe and consider liking the video. Thank you.